Okay, so this is 11-2B. And instead of surface area of a prism, it's surface area of a cylinder. But it's the same formula, okay? The difference is a cylinder has circles, which means a cylinder has pi, right? So a cylinder looks like this. This is going to be your bases. The two circles are your bases. This is the height. This is what's called a right cylinder. If I tipped it over a little bit, it would be an oblique cylinder. And like I said yesterday, we don't do a whole lot with the oblique. But this would be oblique. This is right. Okay, we will focus more in that box. But if it is oblique and you do see a problem like that, your height falls outside the figure. It could fall inside, but it just has to be perpendicular to the bases, okay? Okay, so think about this with me. If you have a cylinder and you make a net for it, right? So I have this figure here that I'm going to turn into a net. What is the lateral area going to be? What the lateral area part of the net, what shape will that make? What is it? A rectangle, right? If I take a cylinder, I cut it, right? And then I open it up. Think about a soup can. The label on a soup can, if you took the label off, it's a rectangle, right? So if I took the net for this, the lateral area would just be a rectangle where this length here, this top length, is what? It's the perimeter of the base, and our base is a circle. What's the perimeter of a circle? Circumference, right? So pi d or 2 pi r, however you want to think about that. This would be a length of 2 pi r or a length of pi d, right? And then this side is the height of the figure, okay? If we wanted to do surface area, then what we would do is add those circles on, so top and bottom, right? So now you're just adding the two bases. You're adding the 2 pi, or the pi r squared twice, right? Because here's the radius of our circle. The area of that is pi times the radius squared. So when you add on your bases, you're adding 2 pi r squareds, okay? So that means our lateral area formula doesn't change. It's still perimeter of the base times the height. It's just that the perimeter of the base now is 2 pi r or pi d. Which, do you have a preference, pi d or 2 pi r?
I like pi d.
Pi d? I like pi d, but my brain just works in pi d mode. 2 pi r is totally fine, but you could write it either way. So pi dh would be the same thing, or 2 pi rh is also the same thing, okay? Just know that on your test, the formula I'm going to give you is that ph. You need to convert p into pi d or 2 pi r, okay? Surface area then, again, is the same formula. It's the lateral area plus 2 times the area of your base, which is the same as saying your lateral area plus 2 times pi r squared. Okay? So really what we're going to do today is we're just going to find the lateral area and surface area of a few cylinders and call it good. 2 problems. Okay? Can I move up from this? Yes? We'll go to there. All right, so first example, this is like example 3 in the book, if you are following along. They're going to tell us the radius of a cylinder. is 4 inches. And the height of the cylinder is 6 inches. And we want to know the surface area in terms of pi. What does in terms of pi mean? Keep the pi. Okay? Find the surface area in terms of pi. Now, if they don't give you a picture, you are welcome to draw a picture. I'm a very visual learner, so I always draw the picture. You don't have to, but if it helps you, draw a picture. So you're doing a radius of 4. Oops. Pretend that looks pretty, okay? And a height of 6. All right, talk me through this. If we're going to start with the lateral area in order to find the surface area, your formula is P times H, right? What is the perimeter in this picture? Perimeter is the same as circumference, right? What's the circumference of a circle? Pi d. So this would be, it's what? 8 pi, or pi times 8. So 8 pi is our P. What is H? 6. Okay? When you simplify it, we're leaving it in terms of pi, so you're just going to do 8 times 6, or 48 pi square inches. Okay, that's your lateral area. Now we need, hey Bella, will you put that away and pay attention to this? Now we need surface area, okay? So your surface area is going to be your lateral area plus 2 times the area of the base. So we're going to take our lateral area, which was 48 pi, plus 2. What's B right now? Pi r squared, okay? And our radius is 4, so pi r squared is 16 pi. So you're doing 48 pi plus 2 times 16 pi, or 48 pi. You don't have to show me all of these. I'm just showing you where I'm getting things from. Plus 32 pi. Okay, if we simplify that, your surface area is what? $80 pi square inches. Okay, I don't need to see 3 different breakdowns from you. You can just show me the one, and I'm good with that. But I want you to see where I'm coming from. So, questions on that?
The 4. Why is that B? What is B?
So B is the area of the base, right? So if 4 is your radius, B is always pi r squared. So it's 2 times the area of the circle, pi r squared. B is always area. So you just got to figure out area of what. In this case, it's a circle. Okay? All right. Last one. Is that good? So this is like example 4 in the book. It says a soup can is 4.5 inches high and has a diameter of 3 inches. I want to know, how much paper do we need for the label? Okay, a soup can's 4.5 inches high, has a diameter of 3. How much paper would you need to make the label? So if you want to draw a picture, you can draw a picture. So this is 4.5, a diameter of 3. what do we need to do? What's it asking us for? The lateral area, right? This one you don't have to do surface area because on a soup can, you don't put the paper on top and bottom, right? You just put it around the edges. So we're going to find the lateral area, and then we're done. What do I do? What's your formula? pH. Okay. What is P in numbers now? It's 3 pi, right? You were given a diameter, and circumference is pi times diameter. So it's 3 pi for P. What is H? 4.5. Okay. So you just need to do 3 times 4.5. Here's the thing with this problem. What is 3 times 4.5? 14.5? 13.5. This is your lateral area, but when we're talking real world type problems, pi doesn't really make a lot of sense. So what you do on a problem like this is you would round to the nearest tenth. So plug in 13.5 pi, and you get a lateral area of approximately 42.4 square inches. So you would need 42.4 square inches of paper to make that soup can, or the soup label. Okay? Questions on that?
Yeah, for that problem, I would just put round to the nearest tenth.
Yes, in the book they'll say, I think in the book they do. For sure on the test, I will say round to the nearest tenth on that type of problem. Okay? Questions? That's what you're doing, cylinders today, okay? Just remember when you see P, it's pi d, and when you see B, it's pi r squared, okay? That's what you're doing with cylinders.